All you need to know at this stage is that he evaluated several sample sizes, really small sample size of 2, and then 4, and then 8, going up all the way to 1,024. Now, if the z-test works with alpha specified at 0.05, which is what we find in this portion of the table, then the number of tests that find a significant result should equal about 0.05. And when Bradley looked at the one sample z-test with a sample size as small as 2, he actually found that the p-value, or the type 1 error rate, was equal to about 0.45 to 0.48 across these 3 distributions, all of which are normal, by the way. The other pieces of information are relevant to the robustness of the z-test, and I'm not interested in talking about that right now. When you increase the sample size to 4, you find that the p-value, or the type 1 error rate, gets very close to 0.05. And once you get up to 8, it's pretty much bang on. We get 0.49. It's supposed to be 0.50. And then once you get to a sample size of 16, we're very much in the 0.5 ballpark. And we stay there going up to a sample size of 1,024. So the difference between sample size of 1,024 and 8 is quite small. But you would even say that at a sample size of 4, it's still pretty much in the ballpark of 0.05. And even with a sample size of 2, it's not as if it's terrible. It's still approximating pretty close to 0.05. So this idea, which is this notion, which is very commonly perpetuated, that for a one sample z-test to work, you need a sample size of 30 or greater, is simply not borne out by the simulation research. And I personally would trust the simulation research before I would trust statements that don't have any empirical data supporting them. So you should use the one sample z-test when you have a mean, a population from a mean, and a population's standard deviation, and you want to make that comparison. Don't use the one sample t-test. You don't have to.